Here we are in Creality Print 5. I'm going to go over the basic process of slicing a model. Each of these models will present different needs and requirements for successful printing. To get started, let's put each of these models on their own plate. Let's assume this is a project that will require multiple parts or has multiple variations that you will be printing individually one at a time. We will want to put each of these models on their own bed. Up here on the top left corner of the screen, you'll see a button that says Add Plate. Go ahead and click that button 2 times. You will see you now have 3 plates labeled as 1, 2, and 3. To activate a plate, simply click on it. Now go ahead and grab each model and move it to its own plate. We will want to orientate these models. Some of them may be printed best by orientating them manually. For now, these are simple objects. Let's go ahead and auto orientate. We will press this button right here that says Auto Layout. And we'll press this button right here that says Auto Layout. And we will press this button here that says Auto Layout. This method will attempt to organize the entire project on as few beds as possible. You will see by clicking Comply, the entire project will organize onto one single bed. When working with multiple plates, I recommend doing it manually at the plate. When working with a single plate, you can go ahead and use this feature just fine. Do take note, if you don't want Creality Print rotating your model when arranging, which can affect your Z-seam placement, do go ahead and uncheck Allow Rotation for Auto Layout. Should you wish to make more than one copy of your model, simply click on your model, click on the Clone button, and tell it how many copies to make. I will say 2 and press Add. You now have 2 additional dogs. Move them around however you like, or you can use Auto Layout. Auto Layout should make a decision that is acceptable for printing. However, it may not be the one that makes the most sense for you. Go ahead and arrange them however you think is best. Let's quickly go over camera and model movement. To rotate the bed, we're going to right click. This allows you to go left and right, up and down. To zoom in and out, simply scroll your mouse wheel forward and back. To move the model, you're going to left click and hold, and you can drag the model around. Fun fact for those of you gamers, you can use WASD to move the model left and right, up and down. However, to rotate the model, you would like to press R or click the rotate icon here, and then use these arrows to click and drag your model. You may also rotate 45 degrees at a time using these buttons right here. Let's take a closer look at why you may want to rotate your model. Should you wish to resize your model, simply click the model and click Scale. Or you may click the model and press Ctrl R. Here you can adjust the size and percentage. For example, we want to make this dog 20% bigger. You will type 120% and then just click on any other field, and you will see they all populated and the model is now 120% size. If for some reason you want to scale this doggo disproportionately, you can uncheck the uniform button and press OK. Now, when you scale this dog, only the field you change will rescale, leaving the other parameters the same. Press Reset to return to 100%. To leave this interface, you may click on Scale or click off the model. Speaking of orientation, here's a doggo. You can see it's very easy to orientate him. He sits on his butt and is good to go. However, we are not going to go ahead and print this knife like this. Go ahead and click the bed. You'll see it is highlighted. We are now working on bed 3, and you'll see my camera focuses on bed 3. This knife needs to be printed on its top edge right here. So let's go ahead and position it here. To do that, click on this icon up here that says bottom, or press B on your keyboard. You will see right here that this is the activated tool. To bring up the available surfaces, go ahead and click on the model. All the available surfaces have been shaded white. When you hover your mouse over one of those surfaces, you'll see they turn yellow. I'm going to go ahead and choose this one. You'll see the model has been rotated and is sitting on that surface. Had I chose, for example, this one, you'll see the model is now sitting on that surface. You can return it to the previous orientation by clicking the left arrow right here. Continuing on orientation, let's highlight this plate and have a look at this mask. I do not want to print it like this. You can see it's printing on a very small surface and leaning forward. Let's say I want to rotate this model and lean it back a little bit. Click on the model, press R to switch to the rotation tool, or simply click right here. We can rotate this model in 45-degree increments by simply pressing plus 45 or minus 45 on the correct axis. However, I want to make smaller adjustments, so I will go ahead and left click on this arrow right here where I can manually move the model. And you will see Creality Print offers you this very cool little graph showing you your angle. I will move it a little bit and let go. You will see the model dropped back to the bed and is now at this angle. Let's say I want to rotate this mask upside down, so I'm printing along the larger surface of its head. I would simply go to the y-axis and press 45 degrees 4 times, and your model is now upside down. I do not want supports on the front of this mask. I will grab this arrow and simply lean the mask back. Now you can see there are no overhangs in the front. Let's talk about supports. This mask will need supports, and this knife will need supports. Click on the knife, click on support, and click on enable support. You have a choice between normal and tree. Should your model have predominantly curved or small contact surfaces, you will choose tree. So we will go ahead and use tree for this model. You want your supports starting at the plate and moving to the model without actually touching the model. As it is defaulted, your supports can be built anywhere, including on the model itself. For example, the supports could build on the nose and go up to the ear. We don't want that. We want the bed to the ear. So we will choose on build plate only. Let's go ahead and have a look at our supports. To do that, press slice plate. Here you can see our tree supports. These supports are pretty extreme. We can talk about the front and the rear, but let's look at this right here. I'm certain that my printer can handle this minor overhang, and I don't need these giant supports. Looking at the threshold angle, 45 is pretty high. We are going to go ahead and lower this to 25. That's a more reasonable starting point. Let's go ahead and reslice this plate. You will see the printer has now excluded that area for supports and reduced the amount of supports on the blade right here to something more reasonable. That is because this angled section of the model here is within that 25-degree threshold. This virtually 90-degree angle needs to be supported, and it is. Let's say you like the way the supports look for the rest of the model, but not this section right here. So we don't want to adjust the threshold angle because it will affect the entire model. We are going to go ahead and use support blockers. To do that, we will highlight the model and click right here on support painting. With support painting open, you will see Creality Print is highlighting in red the areas that fall below that 45-degree threshold in which Creality Print will apply supports. We are going to paint support blockers over these thresholds. However, the way it's defaulted, you are able to paint on the entire model. We are going to click on overhangs only. This means when you paint, it will only paint on the areas with these overhangs, skipping the rest of the model where overhangs are not present. I am going to use the circle tool. I am going to increase my pen size by dragging this meter to the right. You'll see the ball is now bigger. And I'm going to right click and drag. Right click and drag. You will see it's now highlighted dark red. That's a support blocker. Light red is supports. Dark red is a support blocker. If I had left-clicked, it would force supports by painting this overhang green. Let's go ahead and slice this plate with the support blocker here and the forced supports here. Turn off the support painting, press slice plate. Here you can see we have the supports here and no supports here. This is how support blocking works, how support forcing works, and how support painting works. Mastering this is what separates the bad from the good and the good from the great. Do spend time learning how to work with these features. Let's look at support painting and support blocking a little bit more over here with this mask. To bring up supports, click on the mask and click on support painting. Here you will see support overhangs. Some slicers allow you to see support overhangs outside of the support screen. This may be a feature at some point in Creality Print. For now, those supports show up inside the support interface. These shadings indicate the areas in which Creality Print will be adding supports. We can raise or lower the threshold angle to increase or decrease the amount of supports being applied to this model. With the support interface open, this threshold angle is right here, and we can adjust it with a real-time visualization. This is a really powerful tool of Creality Print. It's very responsive, and I'm really pleased with it. This is super helpful in helping you learn how thresholds work and making decisions on how to apply your supports using the automatic settings of Creality Print 5. Here you can see the results of raising that threshold and lowering that threshold. I'm going to bring that threshold down to 25. At 25, you can see it supports the eyes, the mouth, a little bit of the cheeks, and right here at the bed contact, and a tiny bit up here at the chin. Keep in mind that supports aren't only for printing. The main purpose of supports is to avoid printing on the air. The support gives the printer a structure in order to print on to create these things that would otherwise be printed over the air. However, it also provides stability. You can see this doggo here is quite stable with lots of bed contact. However, this mask is standing upright and will be extremely unstable, subjecting this model to movement, which can create layer shifts or complete and total delamination from the bed, failing your print. Therefore, we may use supports that aren't physically needed to print, but will grab a hold of this model at different stages of the printing process to keep it stable and prevent moving as the printer does its work. Let's slice it and see what it looks like. Here you can see the tree supports grab a hold of this, builds a trunk up to here, grabs a hold of the eyes, and then grabs at the top of the mouth, and then grabs at the tip of the mouth. Looking at this model, you can see there's almost no support contact outside of the very base of the skull until the eyes. It's very likely that this model will fail before these supports grab a hold of the eyes and hold this model in place. This is where forcing manual supports with support painting comes into play. I will click on Prepare, click on the model, click on Supports. We will turn off On Overhangs Only and have a look at this model from behind. Using our scroll wheel, we will zoom in, we will reduce the pen size, and simply left click and paint some supports here along the edge of this mask and here along the edge of these eyes, and slice again. Here you can see the results of our manual support painting. We now have strong supports grabbing a hold of this mask to help it stay put until the main tree supports grab a hold of the eyes, allowing it to stay put until these tree supports attach themselves to the model and begin stabilizing. Should you be unhappy with where these supports are placed, you can simply go back to the support painting interface, press Shift, left click, and trim these manual supports, for example, to avoid having them placed at the face of the model. You'll see they're still here behind the mask. Now you can see, having cleaned that up, the supports are not touching the front face of that mask. They are all along the edges and behind the mask, leaving the face of your mask clean. Now let's make a quick decision on support blocking. Let's say you are certain or fairly confident a portion of your model can be printed without supports, but Creality Print puts supports there. Here at the tip of this mouth, I'm certain Creality Print can handle this overhang. Regardless, look where it is. It's behind and underneath this lip. This is not something that will be seen on the mask. So I can save the time and potential fail by eliminating this lengthy tree branch. Back to prepare, click the model, support painting, have a look for that little tiny marking showing where the support is being applied, right click and block it. Slice the plate and you will see Creality Print has now skipped applying the support to the underside of the mouth, and we'll stop right here. This is really great. You can see how much better the supports are now. That giant branch is no longer there, and you can actually get a better look at how it's going to support the eyes at the top and bottom, the mouth at the top, and of course the manual supports here along the skull. This is a great example of supports being used to stabilize a model. As the printer is constructing this model, you will see these supports aren't touching, but my manual supports are, so they're holding on to the model. As it gets taller, you're going to see these supports grab a hold right here to the upper portion of the eyes. That'll hold this model in place as it continues printing. Once it reaches the top, it's going to grab a hold again. It's then going to grab along the inside of the cheeks and the upper portion of the mouth. Now we have 1, 2, 3, 4, 5 points of contact, holding this model put as the most difficult and unstable portion prints, which is the thin top of this model. Apply this thought process when slicing your models, and you will have better success. Let's move along and return back to our dog to continue slicing. We will now look at our quality settings. I'm going to use the 0.2 standard profile. I suggest, unless you have a specific need to use anything else, I'm using PLA. You can choose the closest match to the PLA you're working with, such as generic PLA, hyper PLA, etc., etc., etc. I work a lot with hyper PLA, so I'll choose that. Here is your nozzle and bed temperature. In my experience, I find 220 sufficient for nearly all PLA filaments on nearly all of these newer printers. However, I find 50 for the bed temp to be a little low. I'm going to modify that by clicking on this pencil and scrolling down right here to bed temperature. I'm going to change first layer to 60 and other layers to 60. I'm going to do that for the smooth plate and the textured plate and the customized plate. I don't believe in changing the temperature mid-print. I don't like that cooling and heating process. That can cause expansion and contraction and present failures. I recommend keeping a stable temperature throughout. I will press save, and I'm going to save it as Hyper PLA Me. Okay, here you can see Hyper PLA Me. Close this out, and you will see your specified settings should appear properly. We will now go over the basic slicing functions that you will want to look at for all your models. There are a lot more advanced features, but generally speaking, you won't be needing them all the time. I'm going to go over the features that you will be wanting to look at all the time to get started in learning how to use your 3D slicer. Next up is your Z seam. Right here it's listed as seam, and the seam position is aligned. Because the dog is facing me, and the most viewed section of this model would be the front-facing section, I'd like the Z-seam to be placed behind the dog. Right now it's set to aligned. When I slice this model, you'll see the Z-seam is an absolute mess, represented by these white lines. So I will go ahead and click on this and choose back. Reslice the plate, and you will now see the Z-seam has been placed along the back. If you are unsure what's best for your Z-seam placement, Feel free to tinker by choosing each one and reslicing the model. When you find the Z-seam that looks the best to you, leave it there. Return to the Setting tab and click on Strength. Here you will see many features. The most important features you want to look at is sparse infill density and wall loops. Some people will simply refer to this as walls or parameters. This is how many walls will be printed along the outside perimeter of your model. For example, right here you can see there are 2 wall loops. This is your infill. Infill can be made up of various different patterns. This pattern is known as grid. You can click here and change it to a different pattern. There are various reasons you may want to switch patterns. For now, we are going to stick to grid. The most important part you're looking at on the screen is infill density, and that is the percentage of the hollow space of this model that will be filled with infill. Right now it's set to 15%. 8 to 15% are very common numbers you will be working with. For demonstration purposes, we'll reduce this to 5% and slice the model. Here you can see what 5% infill looks like. You can use your judgment to decide how much infill you need, knowing that less infill is less strength, more infill is more strength. Less infill is less weight, more infill is more weight. I will go ahead and return this to 15%. And now you can see the dramatic difference between 5 or 6% and 15%. This will be a lot stronger and add additional weight. Now let's have a look at walls. Here you can see the 2 walls. Walls add considerable additional printing time to the model, but also add considerable strength to the model since it's a physical structure. Think of it as the model within the model within the model. If I change the wall loops to 3 and reslice this model, you will now see the model is made up of 3 walls. This will make this model considerably stronger. While it might not be a big deal for things such as the body, small parts such as this tail right here will benefit greatly from having that additional wall in such a small, thin section. The same goes for small parts such as the ears. You can see these tiny little ears might be fragile, but with 3 walls, a lot of additional strength will be added. These walls can also help avoid seeing the infill through the model for a filament that might be slightly translucent or exposed to bright lights. The next thing we want to look at is speed. To adjust your speed, return to the tab and click on Speed. Setting your speed is very important. Simply going with default settings is foolish and something I'd like you to step away from. Consider all aspects of the model you're printing, the height, the thickness, the amount of detail, and use that to make decisions on speed. For example, this dog looks quite easy to print. All the features are large and blocky. He's quite robust. There's very little chance of movement, not a whole lot of small detail, so working with faster speeds should be fairly acceptable for this dog. This knife is standing on edge and definitely prone to movement that can create quality issues. It also has to write buck 120 here on the side. Same goes for this mask. It's very thin, very tall, and can be prone to movement. So we want to be more gentle when printing this mask to prevent any unnecessary movement or accidental nozzle contact with the model from the printer trying to work too quickly. Therefore, we can move over to this section right here and adjust our speeds accordingly. This here is our first layer. It quite literally means the first layer. Your poor printer has to print these tiny little paws and this little butt print with these intricate little toes and whatnot in order to create this dog. This is easily the most difficult portion of the print and the most critical part. Slowing down your printer for this first layer is very helpful. You will see the profile already has it slowed to 50. If you feel these details are really small and really complicated and you want to give your printer an easy time, you can simply slow this down. If you slow it down, I would slow the infill down a little too. With experience, you will learn your printer's behavior and capabilities and gain greater understanding of what speeds relative to what tasks your printer is comfortable with. Once this first layer is printed successfully, you will see the rest of the print is much easier as it's going to build upon that first layer. Typically, your profiles are set a little on the aggressive side, and I prefer to slow them down. All you would do is click on here and type in the speed you want. Again, with experience, you will learn what speeds your printer is comfortable with and be able to make these adjustments more easily. When making speed adjustments, I tend to do it in a uniform manner by reducing all of them by, say, 20 mms or 30 mms or a certain rough percentage, keeping in mind outer walls and top surface are the most important part of the quality of the model, since things such as infill and inner walls are not seen. It's typical for your top surface to be slower. If you are struggling with top surface details or you're uncomfortable with the printer's ability to handle a complex top surface, you may lower the top surface more. If you'd like to see more advanced options for all of these tabs, simply hover your mouse right here and click on this slider to move it over, turning on advanced options. I do recommend always working with advanced options turned on so that you can become more comfortable and more powerful a slicer by becoming more familiar with all of these settings. By this time, we should have already worked out our supports. This dog is not using supports. However, this mask is, so we will switch to this plate. We will check supports and switch type to Tree Auto. This can be confusing as it may appear to have not retained your painted support modifications. However, if you click on support painting, you will see that it has. Now we have one more decision to make, and that is, do we need adhesion assistance? Do we need to print something first and then print the model on top of it in order to help the model stay put? We may want that for this mask because it's going to rely on very minimal bed contact for quite some time. We have two options, a brim or a raft. Raft is considered a support type, and rafts are used only in the most desperate and complex situations where extreme strength is needed. This mask may actually be a good candidate for a raft. To apply the raft, we simply scroll down and look for the category raft, and we will add raft layers. I suggest starting with at least 2 layers. To see what that raft looks like, slice your plate. Here, you can see your tree supports are sitting on top of that raft. Should you decide that this raft may not be strong enough, you can go ahead and add additional raft layers. Typically, 2 layers would be sufficient. However, rafts are not the most commonly used adhesion assistance and often overkill for your model. The more common adhesion assistance is a brim. For the brim, let's move over to our knife. Before switching to other, to work with a brim, we will turn off the raft by switching the layers to 0. Returning to this tab, click on Other, and you will see Bed Adhesion. You will be presented with several choices. Over time, you will become comfortable choosing outer brim, inner brim, or outer and inner brim on your own. For the most part, for now, we will work with Auto. To see what it looks like, go ahead and slice the plate. In here, signified by the blue color, is our brim. Unlike the raft, the brim is not printed underneath the model. The model makes contact with the bed, and the brim simply makes contact with the outer portion of the model. Up here in the front, you will see there is no brim because the model does not contact the bed. In this case, the supports contact the bed. For a more clear example, I'll move over to the dog and we'll apply the brim to the dog. Here is our brim, again, on the outside of the model. The model itself is contacting the bed directly. The next option you may consider is mouse ear. It's quite exciting to have mouse ear built into Creality Print. Mouse ear has only come into existence recently. There was a time that you had to create mouse ears manually or use a third-party plugin. Let's go ahead and add mouse ears to this dog. You may leave it default at 0 Or if you feel the need for a larger mouse ear, you may change this number. I'm going to go with 6, so it's a little bit bigger and you can see it more clearly on this demonstration. Press slice plate. There they are. All of the small contact points of the model have mouse ears attached. These are round brims that only surround the smaller contacts of the model. Here is an example of how I used round mouse ears in Cura to support a large prop machete. For example, here we are in Cura, and you can see I used mouse ears to help stabilize this very long, thin machete blade. These mouse ears helped keep my supports in place and keep these little contacts of the ends of the blade from lifting off the bed, and it helps me get a more successful print. Let's go ahead and apply those same mouse ears to the knife. Here you will see the corners that contact the bed have been given mouse ears. These mouse ears will provide extra adhesion during these early layers to help prevent this model from losing adhesion with the bed or warping. This brings us to one last feature, and that is a skirt. Should you be printing a model that doesn't require bed adhesion assistance at all, for example, this dog, you can see this dog has plenty of flat bed contact and doesn't need a brim or a raft. However, we may want the opportunity to observe our first layer before the model prints, or to allow the printer to purge the filament before actually starting the model. This is done with a skirt. A skirt will simply draw the outline of the model around the perimeter of the model without actually touching the model. In Creality Print, we do not have a skirt on or off. We have a skirt loop count. It's perfectly acceptable to do a skirt of 1 layer. However, doing a skirt of 2 or 3 layers can allow you time to cancel or make an adjustment before the print actually starts. Let's see what that skirt looks like. Slice the plate. Here is that skirt. You can see it makes no contact with the model. It allows you to get an idea of what your first layer is going to look like before the model itself starts to print. There are, of course, many more features available to you in Creality Print. However, these are the basic, most critical components of any 3D slicer that you will need to learn to work with in Creality Print 5 to get started on having consistent success with your 3D printer using Creality Print 5.
Hey,